Here we're going to look at the 2012 higher level paper question A-1. So in A-1 we're shown the trimetric projection of an electron, and we're also shown a little diagram on the side to show what the electron actually looks like. So again, this is based on axonometric projection, and this would have been covered in the Junior Cert Technical Graphics course. So what we are given is a elevation, and we're given in view. And what we're just asked to do in part A is complete the axonometric projection. So what I'm going to do, I'm going to project in, and I'm going to call this view on the right, the elevation. So I'm going to start on the electron and the top slanted part. So I'm going to project in my points. That's from the elevation. I'm going to project in the same points from the in view. And where those meet, we actually have points on the axonometric projection. And I'm just going to join those up and heavy those in. So sometimes it's easier to start on the top and on the bottom. So that's the top slanted part. So now if we look down at the bottom of it, we're going to use the diagram, a little picture that's included in the question, to see what the bottom of this electron actually looks like. So it looks like a capital H. So same as before, I'm going to project in from the in view, and I'm also going to project in from the elevation. And there's very little work to do since all of the lines are already in. We just need to heavy in the line off it, so I'm just heavying in this side off the base. So now, when we're dealing with the curve, we have been given a huge head start here, since we've already been given points on the in view and the exact same points on the elevation. So again, to make it easier for ourselves, I'm going to number it. So I'm going to start from the bottom, so that's 1, we're going to have 2, 3, I'm going to label the exact same points. So however high, we'll say for example 2 is in the in view, 2 is going to be the same height in the elevation. So same as what we've done before, nothing new here. I'm going to project in point 1 from the elevation, I'm going to project in point 1 from the in view. Where they meet, I have a point on the curve. So here I'm just showing where the curved stand meets the slanted part. I'm going to highlight these or draw these in just lightly yet before I heavy them in. So I've got the 2 points there, and again I would call that point 6, so that's exactly where the stand meets the slanted book holder. So I'm going to project in 6 first from the in view. Project it in from the elevation, and I have the meeting point or the intersection between the stand and the book holder. So I'm drawing them in only light first, and now just when I heavy them in, there will be a small little bit of hidden detail, so I can see all that portion of the stand. And a small bit of hidden detail included. And that's part A of the question completed. So part B here asks us to determine and indicate true diagonal length of the sloped rectangular top. So again, it just sounds a little bit more complicated than what we were actually being asked for. So if I was to draw it here in the elevation, that's what one diagonal length would be. I'm just joining up the corners. In the in view, that's also diagonal length. It's not showing us much since we can't see a true view of it. That's also a diagonal length there, or that's also a diagonal length there. So any of those. However, we don't have the true surface of this rectangular top yet. So what I'm just going to do is I'm going to draw it in, and I'm going to show you how to do it on both views. So either of this will give us the same solution. So if I look at the in view first. So the in view tells us how wide the top of the lectern is. So that's a true view of the width of it. And I'm just going to draw on perpendicular to this. So and I'm going to put on the length of the lectern here. So where do I find the length? If I look over at the elevation, I have a true length from here. So I'm going to take the length of that, pop it over on these projected lines. And now what I've just drawn in is the true view of the rectangular top. So we call this the book holder of the lectern, or the notes holder. So that's a true view there. And if I was to draw in the true diagonal length, I can draw from any of the corners to the opposite corner. So I'm going to pick on this one, and that is the true diagonal length. So that's one possible correct solution. And again, I'm just going to show you we can do the exact same thing over on the other view. So if I look over at the elevation, in the elevation I have a true length of the rectangular top. The same thing, I'm going to project out these lines. I'm going to take the width, and where I get the true length or the true width, I get it from the in view. So I'm going to take that, I'm going to project it out or step it out. And now first what I've drawn in is the true view of the top of the lectern. And now to answer the question, I'm going to join up opposite corners. So I'm just going to pick this one. We could just as easily have picked the other one. And that is also the true diagonal length. And that is part B of the 2012 question A1 complete.